As for the concept of polarization, whenever there's a difference in electronegativity, just to remind you, electronegativity is the ability of an atom to attract the bonding pair of electrons itself. That depends on mainly the charge, the nuclear charge, and the size. When the cation is smaller in size, greater in charge, and also any atom is smaller in size, greater in charge, and it will attract the bonding pair of electrons itself more, that will result in the molecule to be polar. So for example, if I take HCl, electron pair will be more close towards the chlorine than the hydrogen, because chlorine has +17 nuclear charge and hydrogen only has +1 nuclear charge. That will make the chlorine to have a partial negative charge and hydrogen to develop a partial positive charge. So this is known as electronegativity of chlorine, and we say chlorine is more electronegative than hydrogen because the bonding pair of electron is more attracted towards chlorine than towards the hydrogen, right? And that's the reason for this type of charge separation in the molecule. And this is known as polarization, that is the charge separation which occurs in the molecule as a result of the unequal sharing of electrons. Now here, this is delta. Delta is to show a small charge separation, right? So when there is no difference in electronegativity, like for example, if it's just a chlorine, then the shared electron pair will be exactly at the center. So as a result, the two nuclei attracts the electron pair equally. So that will result in a non-polar molecule. And this will result in polar molecule, right? Yes, don't worry, I'll explain. I'm explaining again from the beginning. So even if you have been absent last week or if you don't understand the concept, now I'm explaining from the beginning. Don't worry, right? Okay, so what is electronegativity? That is the ability of the atom to attract the bonding pair of electrons itself. So chlorine attracts the bonding pair of electrons itself more than the hydrogen does. So that's the reason why chlorine develops a small negative charge and hydrogen develops a small positive charge, because hydrogen's one and only electron is gone away from hydrogen. So this type of charge separation occurs in a molecule whenever there's a difference in electronegativity, right? So that is referred to as a polar molecule, because this molecule you have two poles, positive pole and negative pole. So whenever there is a difference in electronegativity, there is a polarization taking place. For this polarization, uneven sharing of electrons, and as a result, you get a charge separation. That molecule is referred to as a polar molecule. A molecule where polarization takes place is a polar molecule, and that happens when there is a difference in electronegativity. So, electronegative than hydrogen, and hydrogen we call it as less electronegative, or in other words, electropositive. The less electronegative element is referred to as an electropositive element, right? So this is polarization, unequal sharing of electrons, and the charge separation will give rise to the molecule being a polar molecule, right? So this polarization in fact gives some sort of ionic character to the covalent molecule. As you can see, this hydrogen chloride, as I mentioned at the beginning, hydrogen will never form ionic compounds. Hydrogen always form covalent molecules. So always the hydrogen halides, they are polar molecules, right? They are polar molecules, and you can see this polar molecule has a charge separation, and that gives a certain degree of ionic character for this covalent molecule. And as an ionic character that behaves some sort of ionic, it shows properties of ionic compounds. For example, properties of ionic compounds being soluble in water. We know all hydrogen halides, they are soluble in water to form strong acids. Generally, covalent compounds are insoluble in water. But when a covalent compound has ionic character, it behaves like ionic, even though the bonding is covalent. Right? So it gives certain properties of ionic compound, right? High boiling and melting point, solubility in water, right? So all those properties a covalent molecule gets, properties of ionic compound, when there's a charge separation like this. This sort of charge separation occurs when there's a difference in electronegativity, right? So that, I'm just revising the last week's lesson quickly, right? So electronegativity is the power of an atom in a molecule to attract the bonding pair of electrons itself. There are two factors which affect electronegativity: atom, the size of the atom, and the effective nuclear attraction. Small atoms have a great electronegativity because small atoms will feel a great effective nuclear attraction, therefore as a result attracts the bonding pair of electrons more towards itself. That is the reason why electronegativity values will increase across the period. You know, from left to right, the shielding effect is constant, number of shells are constant, the nuclear charge is increasing. That's the reason why the size decreases across the period. From left to right, the size is decreasing. When the size decreases across the period, the electronegativity increases, right? As you go down the group, the number of shells increase, right? When the number of shells increase, shielding effect is greater. What is shielding effect? The nuclear charge felt at the outermost electron is reduced due to the presence of inner shells. As you go down the group, number of shells increases. That results in increased shielding effect. So increased shielding effect will account for the decrease in effective nuclear attraction. So across the period, what happens is that the effective nuclear attraction increases. Effective nuclear attraction increases across the period because of the decrease in size due to the constant shielding effect, and down the group, the effective nuclear attraction decreases because of the increasing number of shells, increasing shielding effect. So as a result, the electronegativities will decrease as you go down the group. Right? Across the period, the negativities will increase. Yes, Usman, you're correct. Polar molecules, they show ionic character. Ionic character. Right? Okay. So when the difference of electronegativity is much greater, I mentioned this last week, if the difference is more than 1.6, the bond itself will turn to be ionic. I think I mentioned about the Pauling scale last week. I mentioned about the Pauling scale as to the difference in the Pauling scale. If the difference is more than 1.6, it is the bond itself will turn to be ionic. And I had a detailed discussion last week about the gap between 1.6 and 2. Below 1.6, Pauling scale values, each element has a value for electronegativity. These Pauling scales will be given at the exam. So the difference between the two atoms, electronegativity, if it is more than or less than 1.6, the bond itself will be covalent, but there will be some ionic character. Because any polar covalent molecule, that means molecule formed when two or more different atoms are combined by a covalent bond, any polar covalent molecule will have a difference in electronegativity. Right? So if the difference is less than 1.6, that means the bond itself is covalent, but there's a difference in electronegativity. That means there's a polar molecule. If it is above 2, difference is above 2, then it's definitely ionic. That means bond itself is ionic. But between 1.6 and 2, I had a detailed discussion last week with the metal or the cation part. If it is a non-metal, then if the cation is non-metal, then the bond is covalent, but it has ionic character. It's known as polar covalent bond. And if it is between 1.6 and 2, if the bond, the metal is, the cation is a metal, like sodium bromide, for example, or sodium chloride, is in between 2 to 1.6. If the cation is a metal, then the bonding will be ionic with ionic character. So that detailed explanation I did last week. And the last page of the tube, I told you I sent a separate email, electronegativity. I hope you have that sheet. That explains the details of it. Right? So whenever there's a difference in electronegativity, that results in distortion of the charges, develop a partial positive and a partial negative charge. Such molecule is referred to as a polar molecule, and a molecule where we see a charge separation, that such molecule is referred to as a molecule where polarization taking place. So any polar molecule where polarization taking place there is two poles, a positive pole and a negative pole. And for example, if you take HS, positive and negative, and the dipole will be more towards the negative. We show the dipole like this by arrow. That is, if you don't want to show the plus delta minus delta charges, if you want to just show the degree of polarization or the direction of polarization, you can just put an arrow and put a line in the middle. As this arrow shows, it will always point towards the negative. There's a negative iodine, and it will point the electronegative iodine, and it will point away from the electropositive hydrogen. So you can show either as an arrow, or you can show as plus delta minus delta charge separation. Right, so the most important part begins from this question. Explain how polar bond results in terms of electronegativity. Whenever there's a difference in electronegativity, then that molecule will be a polar molecule. There's a plus delta and minus delta charge separation. When covalently bonded atoms have different electronegativity, a small positive charge, the positive will be developed on a low electronegative atom, that's called electropositive, and a small negative, the negative charge will be developed on the higher electronegative atom. When both plus delta and minus delta charges are present, the bond is said to be polar. The bonding electrons are more drawn towards the higher electronegative element, resulting in the other atom to be plus delta. We should write in brackets here electropositive. The less electronegative element is referred to as electropositive element. So when a covalent bond is formed between two atoms of the same electronegativity, that will be nonpolar, because the reason, right, like in the case of hydrogen, the two atoms will be attracting the electron cloud equally. Electron density map will be like this. This is nonpolar molecule. Electron density map shows the probability of those electrons in the molecule to be present. But if it is a molecule like this, then it's a polar molecule, then electron density map will be more, electron density will be more towards the negative, resulting in charge separation like this. So such is referred to as a polar molecule. So whenever there's a difference in electronegativity of a simple covalent molecule, that will give rise to polarization. So when a covalent bond is formed between two atoms with the same electronegativity, the pair of electrons in the molecular orbital is equally attracted to both the nuclei, resulting in no charge separation. Such molecules are said to be nonpolar. If the atoms in a covalent bond are different elements, the difference in electronegativity will result in the charge separation. Higher electronegative atoms will attract the electron more than the other, resulting in a polarized covalent bond. So hydrogen, same element, there's no difference in electronegativity. That will be a nonpolar molecule, covalent nonpolar molecule, and HCl, the polar covalent molecule. We can copy the electron density map of these two. So let me explain to you the difference between the polarizing power and polarizability. I explained all this last week, but I'm repeating this because some students need explanation again. And plus, you know, this question, this concept is the most important concept in the AS, because you see many questions even in A2 papers, because we know A2 papers are synoptic papers. Synoptic meaning they'll question your AS work in A2. So this is a very common question in A2 as well, because this concept of polarizing power and the polarizability is used to explain so many things in A2. Right? So this is very important. So remember, the first and most important thing is you should know where to use the polarizing power term and where to use the term polarizability. Now, polarizing power is a term which is used only for the cation. Therefore, if someone uses the term polarizing power for the anion, it's wrong. Right? There's a question before I start that I want to clarify. The all the chlorine big because it has a big atomic radius. I know. I do chlorine huge. It is not the atomic radius. It is the electron density map. What is electron density map? There are 17 electrons in 18 electrons in hydrochloric, right? The 18 electron, the electron will move more closer towards the chlorine than towards the hydrogen. It's not the size of the atom. This is the electron density map. That is a map which shows probability of those electrons to be present in the molecule. Now, the hydrogen I have drawn about 30-40 electrons. Now, each dot represents the electron. Each dot represents the probability of the electron to be present at a given time. Now, hydrogen has only 2 electrons, right? But why did I draw so many dots? There are over 100 dots now, right? Why? Because each dot represents the probability of those 2 electrons to be present at a given time. So they are symmetrically arranged. The 2 electrons will move symmetrically in the whole molecule. HCl has 18 electrons in total, but I have drawn about 50 electrons now. Each dot represents what? Another electron. Each dot represents the probability of an electron to be present at a given time. So here, the electron will be more close to chlorine. More electrons will be moving more close to chlorine than hydrogen because chlorine has a plus 17 nuclear charge that attracts the electrons, more electrons from the entire molecule more towards it. So that is what gives the polarization. Plus delta and minus the charge separation. I hope it's clear. Okay. So back to the polarizing power and the polarizability. So the polarizing power is a term which is used for the cation and the polarizability. The term used only for the anion. So this is the first step. You should never use the term polarizability for a cation, or you should never use the term polarizing power for the anion. That is the first mistake done by many students. So you should know which term to use where. That's number one. Let's see what is this polarizing power and polarizability means. The polarizing power is defined as the power or the ability of a cation to polarize an ion. I repeat again. Polarizing power is the ability or the power of a cation to polarize the anion. Now, what is meant by polarizing the anion? That means it causes distortion of the charges in the anion. What is meant by distortion of the charges? You can see here, this charge is distorted in HCl, more towards chlorine. Electron density map is distorted here. So polarizing power of the cation is a power or ability of a cation to polarize the anion. Polarizing the anion meaning causing a charge separation or distortion of the charges of the anion. As for polarizability, that is the ability of the anion to get polarized by a cation. Anion, ability of anion to get polarized by the cation.